The practice of practice is my talk today. We're going to be talking about teamwork and complexity. My name is Matt Davis. This is a little bit about me, my word wall, so to speak. I am operations and IT and product operations for a company called Verica. We are what we call a continuous verification company, which has a lot to do with chaos engineering. I'm going to be talking a little bit about chaos engineering in a little bit. I want to talk about teamwork, talk about improvisation in music, also talk about something called a chaos engineering game day, and how all this ties into what we all think we know of resilience. So first about music. Any musicians in the audience? One or two? People that like music? That's about everybody. Cool. You know, music is something that is very human. Nearly everyone in the room raised their hand when I asked if you liked music. Everyone seems to have a very visceral connection to music, especially improvisation ensembles. Now, the interesting thing about improvisation is its ephemeral nature, meaning it's quickly to go away, right? It's not something that got scored or written down. It's something that is quote unquote made up. But believe it or not, improvisational teams are very much like the teams that we in software are in to help maintain and operate the systems that we write. But let me try to give you a little bit of an introduction to improvisational music. And you may know jazz, but you may not know all of improvisation. Where I want to start though is just a dictionary definition. The activity of making or doing something not planned. A lot of people think about improvisation as, oh, it's just something that got made up. It's just something, do whatever you want. That's what improv is. It's not quite that. We're listening to a piece by composer at the top of the screen. His name is John Cage. I don't think my laser's working. So that sounds pretty made up, doesn't it? It sounds like maybe those people were just singing whatever they wanted to sing. That's kind of true, but it's not really true because John Cage was very specific in his scores about when things happened. So even though the performers have a lot of freedom to do whatever they want, they don't have a lot of freedom in the way that they do it or the times at which they do it. Some other composers in this category of composed chants and indeterminacy are Pauline Oliveros, there with the accordion. She and Stockhausen, who's up there on the other corner, they wrote these intuitive pieces where there were texts, they were like paragraphs, and they instructed you how to make sound. Sometimes Pauline called these sonic meditations. We also have Joan LaBarbera right there in the center, who specialized in these weird vocal pieces that John Cage wrote. And then down there in the other corner, we have a piece known as Cobra. The gentleman holding up that yellow placard, his name is John Zorn, and on that yellow placard are instructions on how to play, not what to play, not in what style or what instrument. Those are all left up to the performer. So that's the kind of improvisation these composers would use. Improvisation is also adaptation in a constantly changing environment. You know, we kind of do this all the time. When we hit an obstacle or something happens, we don't really have a prescription for what to do. We don't have instructions for what to do next. We improvise. We try to figure out something. We look at what we have. Oh, there's some tape. I'll just tape this together. Easiest, right? Band-aids might be improvisations. There's a category of improvisation known as free improv. Free improv usually doesn't have a score, so there isn't a John Cage or a Pauline Oliveros giving instructions about how to play. It's usually just playing. But then you'll get different styles. So free improv or non-idiomatic improv isn't beholden into one style. It's kind of attached to the person who's playing the music. We just heard Derek Bailey, who's the guitarist in the picture right here. Some of these other people you might recognize. Laurie Anderson is here in the center. She does a lot of different kinds of music, but is also known as a free improviser. She comes up with her own style. You know Laurie Anderson because you know Laurie Anderson's style. Some of the other musicians that are up there are Laurie Spiegel, Ikue Mori down here in the corner, who does a lot of laptop music, takes guitar pedals and plugs them together, stuff like that. The Feminist Improvisers group from the 70s is up there. And next to her is Ornette Coleman. He's kind of known as the grandfather of free jazz. So the third type of, or the third definition of improv that I really want to stick with you as I start talking about technology teams is this third one, this development of group intuition. It's where people who play different instruments or sing or whatever, they get together and they practice and they play the same kind of music together. So you probably are starting to recognize a lot more people on this slide, I'm guessing. We're hearing music by the quartet. They're over there on the side. They're known as Masada. Now, the interesting thing about this music is that it has, I don't know if you can hear that Jewish overtone to the scales. It has kind of that, is this a Middle Eastern sounding thing? But it's definitely jazz. So John Zorn, being Jewish himself, decided that he would get a group together and they would do this kind of jazz that's, by the way, influenced by Ornette Coleman, the free guy in the other slide. But they put this tinge to it. They have learned these Jewish scales, and when they get together, they have like this basic contract that they know, well, they're going to play jazz, but they're going to play jazz like this. There's other musicians up here that are like this. Bela Fleck is one of my favorite bluegrass artists, but he plays jazz too. Over here on the side, Reggie Watts and John Tejeda just got together the past couple years to do, if you don't know Reggie Watts, he does this improvised vocal music where he loops himself. So he'll loop his voice, and then he'll improvise over the loops that he's making. Ravi Shankar in the middle, rest in peace, was a sitar player. I should also point out, unfortunately, we lost another great jazz great today, McCoy Turner. And McCoy Tyner, I always say his last name wrong, he played with John Coltrane. Again, really instrumental to this type of what's known as idiomatic improvisation. Now, these words are Derek Bailey's words. Derek Bailey, that guitarist, he wrote this book called Improvisation, and he interviewed all these different musicians about what they do. He interviewed an Indian raga player, that would be the kind of thing that would play on the sitar. He interviewed organists that improvised. He interviewed Baroque musicians. Improvisation was very important in early music, especially Baroque music like Bach, Handel. You hear of those guys, and women like Clara Schumann, who's up there in the top next to Mozart. They pulled improvisation into their compositions, but they did it in the style of their work, whether it be some kind of classical. Ella Fitzgerald is known as, the expert scat. I mean, she basically invented scat singing. Scat singing is when you improvise with your voice. It's like having a trumpet, but you're singing. Some other musicians up there, Missy E, of course, is a rapper. People don't really associate improvisation maybe with rap, but it actually grew out of improvisation. And a lot of the rap that you hear is improvised, and it just gets written down, recorded, but it usually starts out as improvisation. So the interesting thing about these idiomatic improvisers is that they work in teams. Of course, you get solo players who play solo music, but I like the teamwork, especially in something like the Masada ensemble there, where they actually they have the goal of playing in a certain style. So they learn chords, they learn melodies, they learn rhythms, and they get together about them. Now, this is not unlike technology teams. Is anyone in technology teams in here now? Okay, cool. What do we have? Everyone kind of yell out what you do. Project manager, all right. What's that? Testing, cool. Developers, cool. Operations, security, great, awesome. Any product people in here? That's okay, product people don't come to these things. But the reason that I'm kind of mentioning and I want to know where y'all are coming from is because it's this diversity of types, this diversity of people that make up all these technology teams that we are in to deliver our software or run our platforms. They're known as a sociotechnical system. Now, sociotechnical systems are all around us, especially these days. We're in a sociotechnical system right now. You're in a sociotechnical system when you have your phone and you're looking at your phone. More and more people are becoming more and more reliant, might be the wrong word, but engaged in technology. The fact that we're in a sociotechnical system is becoming apparent to more and more humans across the world every day. So as we write and design software, we have to think about these things. Not only are the people that are writing the software interacting with technology and running the software, they're interacting with technology, so are the people that are using the software. They're all interacting with the technology. And there are all these different groups of people. It's not just software development, it's not just NetOps or the NOC or SRE or even incident response. It can be the folks that do data, the folks that are doing the back end, the folks that are doing the front end, the folks that are selling the things, the folks that are running them in the buildings where these machines run. These are all people that are all part of this big, huge sociotechnical system. So we kind of have to decide for ourselves when we start talking about these systems, where are those boundaries? Where are the boundaries of these systems that we're talking about? Because it can be huge. The universe is a system, right? We in this room are one. So one thing that's very common about all these different people, all these diverse people that are in all these diverse teams, is that they all have these different mental models. And I'm like, you know what? Musicians do that too. Let's think back to the jazz groups that are getting together to play, especially that group called Masada, where they've got not just jazz chords, not just jazz rhythms and harmonies, but playing along the lines of those Jewish overtones. It made it sound like the heritage of John Zorn's family. And these are the kinds of things. I kind of tried to make these equal, you can kind of tell, but that's not supposed to be any kind of official equality. I'm just trying to show you that people in technology teams have mental models. Everyone in this room has a different mental model of something, especially a socio-technical system. When you get into an improvising group, they all have different mental models about how they're approaching the music. It may depend on what instrument they're playing, how long they've been playing the instrument, how much practice they got in the night before. I mean, they all have a mental model about how they're coming in to work together, to play music together. Richard Cook is an anesthesiologist, practicing anesthesiologist, medical doctor, who actually has been looking at software in the past few years. And this is his diagram. It's another way to think about these mental models that I'm talking about. He has a lot of stuff going on here, but the thing that I wanted to point out on this is the different little, cartoon, what are those called? Balloons, bubbles, or whatever. And you see there's different models of the system in each of those people's heads. So when we talk about the entire system, we're talking about what those people believe the system looks like below that line of representation, which they cannot see. You cannot see your code run. You can see your program run, but are you actually seeing the code run? Now just think about AWS. Take that way out. How much of AWS can you not see? What kind of mental model do you have of AWS, a cloud service, if you don't know what I'm talking about, versus the person sitting next to you, versus the person who's been on AWS for 5 years and someone who's only just started using it? So what we do when we get together is we're building this basic compact. We have the chords that we know to learn, with the scales that we know to learn, and the rhythms that we're familiar with. We bring that to practice with us. We get into practice and we're paying attention to what's going on. We know what's transpired during that practice, the rehearsal, whatever it is, and we know what's changed since we've started. We're constantly keeping track of what's going on because we have this goal, right? We want to make a good piece of music. We're not just going to sit there and all noodle and play different things. That would be useless. So one of the not cool things that happens when we're in these groups of people, and it doesn't just have to be technology, is that we're trading this information. But sometimes we're not very good at trading that information. We're not very good at communicating with each other, even though it seems like we should be perfectly good at it. People make assumptions, really, really easy assumptions, and they're not trying to hurt or harm anyone. They just believe that someone else believes what they think they believe they believe. So there was this book back in the 90s called Using Language. Herbert Clark did a lot of research in language. Now, he proposed very eloquently and in extreme detail that when humans get together to do something, when humans, more than one person is getting together to do a joint activity, that there are these rules that govern the way that they work together. Now, fast forward 20 years, and you get papers like the ones that David Woods collaborated with others on, talking about the same idea of common ground. Now, common ground is that information that we keep sharing as we're doing a joint activity. And what they tried to do is they tried to take the language that Clark introduced in this book and talk about it in terms of software systems. Really, really great book, really, really awesome paper. I'm not going to go really deep into these right now, but I am going to introduce you into joint activity. So what the book and the paper talk about are these different joint activities. Specifically, Clark in the book talks about someone coming up to a counter to buy something. In the paper, they talk about relay runners in a relay race, where they have this basic compact. They don't have to discuss what they're going to do on the track. They've already practiced. They already know their signals. They already know that they don't have to run up behind someone and explain to them that they're 3 feet behind them. Hey, I'm going to give you a baton. Are you ready? Okay, take it. Okay, now run. They don't have to do all that. They can just say, baton, and the baton's there and the runner's gone. That's because they built a basic compact and they've worked on their common ground. Jazz music is like this. You get together and play. Now, improvisers get so good at doing that, yeah, they could meet new people and get together and just play music, and oh my God, it sounds great. How do they do that? Well, first of all, they intend to work together. And it's not parallel action. It's not you do this over here and I'm going to do this over here, and then we'll see what we end up with on the end. It's not like that. They intend to be together in this activity. Their work is interdependent, meaning you need what I'm going to do in this joint activity, and I need what you're going to do in this joint activity. They are also committed to common goals. This is a really important part of joint activity. you kind of have to waylay your own goals sometimes in a joint activity to get what the 2, 3, 4 millions of you want at the end of that joint activity. That means that you have to give up some of those personal goals to get to the end. And all of this is achieved through effective coordination. This is all a dance. It's all choreography. There are beginnings, middles, and ends to all these little joint actions that layer over each other, intertwine, interact in a complete joint activity. We're in a joint activity right now. When you're out in the hallways, you're in a joint activity. Just think about the next time you go into a convenience store and you start talking to the person behind the counter and think about these things. And when I started learning about this, that was just everywhere. I was just noticing joint activities all over the place. And it was great. But this interpredictability, knowing what that other person is going to do, the directability, being able to tell, hey, you know what, we're doing the wrong thing. Let's change course. Being able to be directed and being able to direct is important, but also maintaining the common ground. So David Woods, who I'll talk about a little bit about later, I introduced him with the paper. He likes to say that common ground is kind of like a verb. It's actually common grounding. It's not a thing. It's something that you build. You are constantly building common ground when you're in these joint activities. And time matters. Time doesn't stop. When you have an incident, when your machines go down, they're not waiting for someone to fix their common ground. They're not waiting for assumptions to be fixed or for course corrections to happen. It's just going to keep happening. So let me give you some examples. Does anyone know String Cheese Incident? Band? Someone back there? Awesome. Improvising band. That's why I chose the name. At least there's one person here. Okay, so this is kind of a hypothetical. Imagine that I'm a guitar player, and I'm playing with a band. It could be any size band, and the band leader, is directing the band in certain ways. It's an improvising band, so we're always changing the way things happen. And all of a sudden, the string breaks in the middle of the performance. So I'm going to pay attention to the string breaking because I can't play with a broken string. I kind of have to attend to that. So I'm going to start playing with my broken string, start replacing my string. Well, while I'm doing that, the band leader decides on, okay, you know what, we're going to play this next section in a different key. We're going to change the way that the music sounds. Everyone hear that okay? Maybe this person's not saying this, but with certain signals, eye gestures or kind of like whatever, the band conductor has said, we're going to change up something. But guess who didn't hear it? Now, the band conductor is assuming that everyone heard what they said. I did not hear what was going on. I'm paying attention to fixing the string. Well, the way music is, I can fix a string and nothing's going to happen because the band conductor said, I'm going to give this hand signal to make the change. I didn't see any of that. Well, we keep playing. Nothing's wrong. Sounds great. Okay, cool. String sounds good. We get to that point, and then the guitar is completely out of tune because I didn't understand what was going on, but the band director thought I did, so everything just kept moving, and then all of a sudden we get to this transition, and it sounds horrible. It's what's known in this as a coordination surprise. And there's different things that we can do to fix this, and I'm going to go into that in a little later, but let's switch over to software, because that's what I'm really here about. It's what Scale's about, after all. Little Feat, anyone heard of Little Feat? More people, cool. Little Feat, another band where improvisation is a very, very important part of what they do. So this is something that happened to me. I was an SRE at a small startup, and something went down. I believe it was just like a front end, something or other, and we had to end up redeploying these machines. It wasn't something that could be just tweaked and fixed. It had to be a redeployment. Okay, fine. So when I came on board, I was trained on how to do this. There's a page in the wiki. I go to the page in the wiki. By the way, I was at a conference when this happened, and I had just gotten food poisoning, and I was the only SRE. So I was the only person on call, the only person who could take care of this. Okay, so again, sociotechnical system. Humans are part of the system. Humans don't perform 100% all the time because things happen to humans like getting sick. So anyway, I'm already under duress and I'm trying to figure things out. Now, the engineer who built this system knows about this deploy tool, but doesn't know that I don't know about this deploy tool. So we're moving through this incident. The arrow of time keeps going. The database starts making messes. Something's wrong with the database. It's taking too long to do things that we think it shouldn't take that long to do. So I'm like, oh my, but that engineer is thinking, wait a minute, what's going on? This should be a very easy redeployment. I don't know what that person's, I thought, man, I don't know what's going on. We don't know the same things, but that engineer assumes that we do. I don't know that piece of data at all, so I don't have assumptions at all. I'm just trying to deal with the situation. It keeps going further. It's getting worse. The situation is getting worse. Finally, the engineer is like, dude, what are you doing? Why didn't you go and use the deploy page? And I don't know if anyone else has ever been in this situation, but that's not something you want to hear in the middle of an incident. That you could have just hit a button and the whole thing would have been finished with 3 hours ago? No, that's not what you want to hear, especially when you're taking every 20-minute breaks to the bathroom. Guess what? That's a coordination surprise. Now, coordination surprises suck because coordination surprises typically mean you have to stop and you have to regroup. Stopping and regrouping is bad, especially in incidents, especially when you're dealing with things like outages. So how do teams get around this? How do teams foresee that this is going to happen? I couldn't have foreseen that I had not been trained or shown that this thing existed. How could I have known that? Well, one way that musicians do is they get together and practice. So this is a famous quote by Miles Davis. I don't even know if it's attributed to a specific point in time or an event or if he wrote it, and I tried to look a little bit into it, but I wasn't very successful. But he's well known for having said this in one form or another. No wrong notes in jazz, right? Well, the whole idea behind there's no wrong notes in jazz is that, well, it's not just because you're Miles Davis and you can play whatever you want. That's not what he means. What he means is that in jazz, it's adaptive. Jazz is an emergent type of music. It is something where you make discoveries, where if you play a wrong note, wait a couple seconds, it's going to be the right note. That's kind of what he means. Well, I thought of this quote when I thought of a gentleman named Bob Edwards talking about the difference between the failures in complex systems and the successes in complex systems. Bob Edwards, to step away from software a different direction, goes into, and this team, human and organizational performance coaching that they do is focused primarily on factories. And an accident will happen at a factory, and Bob and his team will go in and have a learning review with the groups at that factory. And the learning review isn't to figure out what someone did wrong. It's not to point out the human error. It's not to sit around a table and figure out the root cause. Don't tell anyone I said that. But it's to get together and understand the regular work of the system. It's to get together and understand, well, how do you do your job? You know, just show me how you do your job. Because these complex systems, you know, they get a mind of their own, right? You know, they're going to kind of behave how they behave. Well, they're not behaving any differently when they break. They're behaving the same way. Dr. Richard Cook has a kind of a famous quote where he says, it's amazing that any of our systems work at all. That's especially true of software, I think. So Derek Bailey is actually the person that uses the phrase, the practice of practice. When jazz groups get together, and I'm using the jazz group because I think that's the most recognizable form of this improvisational music. When these jazz groups get together and practice, they're getting to a point where they're not really doing anything different when they get to a show. When they get to a show, it's like they've been practicing. It's just another iteration of their practice. You think about dress rehearsals and things like that. Well, what if the dress rehearsals, what if it's just not a big deal? What if the next performance is just another time that the band's getting together to jam? What if incidents were like that? What if incidents were not events? What if incidents were just another phase or another variation, is what Bob Edwards would say, another part of the variability of the complex system? It just happens to be a variability that we don't really want. So Derek Bailey says that improvisation has no existence outside of its practice, and that's what the practice of practice is about. It's about the fact that we are getting into a mode where we're discovering new things, and we need to be able to work together to get to a goal because we don't actually know what that goal is. It's like when you're in an incident, you may not know what the fix is. You may not know what's going to be the fix. And when you fix something, is it really fixed? When does an outage actually end? Is a question people always ask. This concept of real work is really, really important to understanding complex systems, because when you're sharing common ground during success times, when you get to a failure mode, you're going to know what to do. You're just going to keep doing what you're doing. You're going to keep sharing the common ground. You know, you're going to say, hey, by the way, Matt, why don't you go ahead? There's this other thing. Did you know that we could do this? The presence of mind is maybe not the right term, but the intuition of being able to do something like that is what we seek. Okay, live demo time. Now, this is not a computer demo, I'm sorry. That's why it's going to work. But in a lot of these talks, people talk a lot about complex systems. People talk about complicated systems. You talk about simple systems. You might talk about highly coupled systems, loosely coupled systems, these various types of systems. Anyone ever heard of a Cynefin chart? Okay, one or two. Okay, Cynefin, and it does not look like it sounds. The word, it's like it's weird, isn't it? C-Y-G. Yeah, Cynefin. It's like Kevin with an extra syllable is what it is. This is a little bit Cynefin-ish, but I think it's a little bit more understandable, immediately understandable. I'm sorry if the live stream can't see this, but I'm hoping the people in the room can see this. This is a cube of solid copper. It's an element. You learn about elements, hopefully you learn about elements in your grade school or hopefully that early, maybe junior high, maybe high school, whatever. People learn at different rates. But copper is an element. When we think about copper, it's very, very specific. People see a penny, they think copper. people see something like this. You probably ought to, if you could see it up close and you can tell the glisten of the metal, you're like, oh, that looks like a piece of copper. I put a multimeter on this, and it has pretty low resistance, just like a cube of copper would have. Will it stay up there? Yes. Stay. Okay. Does anyone know what this is? All right. This is a Rubik's Revenge. So it's a little bit different than the Rubik's Cube. I like to think of these as complicated systems. These are complicated systems because, well, they're complicated for many different reasons. But one of my favorite things about these being complicated systems is that they have one solution. All the sides have to be a solid color. I mean, we can all agree that's like the puzzle of these cubes, is to get every side its respective solid color adjacent to the other color that it should be next to. And I say that about this because the Rubik's Revenge has no center. So you have to also figure out which color goes on which side. There's all different kinds of ways that you can solve this, but guess what? There's only one solution. Not only that, there's so many different variations of styles of these. Ooh, is that one going to stay there? How about that? That's a 6-sided one. All right. Thank you. This is a, wait a minute, this is a, yeah, thank you. Stars, hexagons, cool. Will this stay up there? Maybe. All right. Many variations. Just like complicated systems. There's many variations of these, but guess what? They all have the same solution. They're all going to the same place. They're all solved different ways. There's different, what they call algorithms, to solve each of these different types of puzzles. If you were to remove one of these, if you were to take one of these corners and flip it around and put it back in, you would not be able to solve it. You wouldn't be able to solve the complicated system. It would be impossible. So now, let's graduate to complex systems. The complex system of this shaker is interesting. Now, I've already given you one of the clues that this is a complex system in that it depends on time to be a system. It depends on acoustics. You have to be able to hear it. I have to be able to shake it. It has context. It has to have a person to do, I mean, it could be on a dog's back or something, sure, be on a dolphin's back, but what happens if it were in water? What happens if it were on someone's head? You know, these cubes actually have the word top on one side. That's weird. Why would a cube have the word top on the side? Well, they don't sound the same, depending on how you hold them. In fact, different cubes sound different. This cube has a different sound than this cube. This one's a little bit higher in pitch. Maybe the beans are smaller, but I can't see them. They're below the line. So there are things that are assumptions I have to make about these systems in order to learn how to play. Shakers are notorious for being able to get them to go. Kind of, you know, the band's playing, I can't really get into a rhythm, and then finally, you get into that place where the shaker actually begins to make sense, you know. But I had to sit there and figure that out. I had to experiment to figure out how that complex system worked. Will this stay up here? All right. So there we go. That is your live Cynefin chart of complex systems. The Cynefin chart, if you go out and search for it, it's very similar. It starts with something that's very simple, and then it graduates up to something that's complex, like a motorcycle is complex. You can take apart a motorcycle and put a motorcycle back together again, it'll be a motorcycle. Stuff like that. So let's dive into chaos engineering. Has anyone ever heard this term before? Okay, good, cool. Does anyone know what this term means? So this is the definition. This is actually on principlesofchaos.org. Chaos engineering is not creating chaos. It's not, oh yeah, we have plenty of chaos engineering. They're our customers, or they're our junior engineers. That's not chaos engineering. That's just chaos. Chaos engineering is knowing that chaos will exist in your complex system. In fact, a lot of complex systems are the most efficient when they're right on the edge of chaos. So chaos engineering is a scientific way to look at this system and try to tease chaos into happening so that you can see what the effects are on the rest of the system. Now, Netflix made this famous with something that they called Chaos Monkey. Chaos Monkey is this little piece of software that, primordial, I would even call it, that you could write in a 6-line bash script. Maybe some of you could do it in a 1-line Perl thing. But it just goes out and kills AWS instances. When Netflix decided that they were going to stop mailing DVDs and they were going to do streaming on AWS, they realized, especially back then, AWS's machines don't stay up. And we have to be able to provide a reliable service to our customers. So they forced things to break. They forced machines to go down. Now, this is an opt-in service back then, right? They would tell a service owner, a team, you need to opt into this. Your system really needs to be reliable enough to stand this, but once all the checkboxes are marked, then we're going to unleash Chaos Monkey and it can start killing stuff, and we can see how well your system stands up to this. But not only that, but to discover things about your system, to discover weaknesses you may not know about, to discover strengths you may not know about. It's a science. It's not something, it's not guesswork, and it's got specific rules to it. These are those rules, and I'm going to go through these in a real-world example. This is something that, again, something that I was a part of. But at the very core, even if you're not talking about a game day like I'm going to talk about in just a sec, chaos engineering types of tenets. Okay, so at this large company that I used to work at, we had data centers all over the world, and these data centers had data in them. And this data was replicated back and forth between these data centers. And the reason for that was because if a data center goes down, then the traffic would be redirected to a different, one or more other different data centers, and presumably the service that we were providing would not go down. Data center goes down, service isn't affected. Now, of course, the only way we're going to know that is by having observability in steady state. And that's being able to, observability is a very, very rich word that can have a lot of things mean, a lot of different things in a lot of different ways. But it really means you have to have eyes on the system in a meaningful, business important way. For example, traffic that flows into these data clusters that represents a certain type of enrichment for these people. That meant that you may tell that I'm talking about ad tech right now, but when you talk about enrichment, you talk about money. And if the people aren't showing up in these databases, they're not getting enriched, which means we're not making money. That's the steady state. These graphs are the steady state. Well, then we have to form hypotheses. When you do a big data center failover thing like this, you kind of want multiple things because it's a big event. So you try to knock out some of these hypotheses. We believe that the other colo has the capacity to take the traffic. We think that the revenue graphs will not show any deviation. We believe that the data system will continue to get the data at the same rate and in the same way because we know that that means money. So we have to go through our methodology. We have to think about how are we going to do this. So for multiple region failovers like this, now I'm talking about hardware data centers, but I could just be talking about clouds. AWS, multi-vendor clouds even. You need some kind of methodology, and we use DNS weighting to do this. You would weigh traffic to and fro amongst the different regions, amongst the different data centers, to understand how that traffic affected the other data centers. And one of the most important parts about these exercises is bringing multiple people together, bringing diverse minds together to do this. It's like the diversity that we have in this room. We've got people from different areas of the technology stack. You all have these different mental models. So getting together to do exercises like this means that you are bringing new information to your colleagues. That I didn't know that did that. I wasn't aware that I didn't know that you could. I didn't know that that feature touched that database. You learn and discover these kinds of things that you wouldn't normally do because you're not normally talking to these people. Probably the most second to observability is being able to get out of it and not affecting more than you need to. So blast radius is really important. In this kind of case, we don't want to go, oh, let's see what happens when half the US goes down. Let's just stick to one region. And in fact, let's do it really slow. Because let's not do like all or nothing. Let's kind of go by percentages, 5% traffic, 10% traffic, 15% traffic, slowly, and see. That's like a blast radius. But also, we've got our hand over the big red button. It's like, okay, we're overloading the other data centers. We've got to go back. And that definitely happened. Sometimes you do that on purpose, and that's what these exercises are for. It's for poking. It's for poking the edges of those boundaries and seeing where that extensibility exists. Now, what happened when we verified this stuff? We knew that the other data centers could take the traffic. The configurations were correct. In this case, we learned how to use the tools. Maybe we had a junior engineer actually type the command in the DNS provider to do this. Because what happens when that person is on call next, it's 3 a.m., and they have to do this themselves during an actual incident. Well, now they've had practice doing it. We also get to do this kind of canary business where you get to see how things actually affect your system. Well, I wrote this piece of the stack to be able to handle this level of traffic, but I can't do that in staging. I need to do that in production because I won't know what I know in production because it's not production if I don't do it in production. Testing in production is what chaos engineering, that's where the real value comes. Now, I always like to say, I'm in operations in IT. My definition of production changes depending on who my customer is. Because my customer may be y'all. I may be providing you a service. So the people inside the company that may mean to me, my staging environment is production to me. It's not to other people, but it might be to me. So what did we discover? Well, we discovered inconsistencies and irregularities. You know, one of the signals that we're not doing that we should go back to the other data center and get the traffic back is the revenue graphs don't look like we didn't think they would look. We didn't think that they would do that. Oh, but look, did you all notice that the non-US colos were holding data they could not use? Well, guess what? We actually discovered during these experiments, during these testings in production, that we were unnecessarily replicating traffic, data and traffic, lots of it, for no reason. So what happened is we saved a lot of money because we didn't have to expand those clusters at the same rate. We could just say, hey, you know what? We're good. We're going to turn off replication that we don't need, that we have not needed for several years, and we get a return. Go back to the slide, our basic compact. What we're doing during these exercises, which has become kind of an art form. You'll see some companies out there actually have game day templates. They'll spend 3 hours on a game day. I don't recall. I think we probably, Tots, do you remember 4 hours for one of those? Maybe 3 or 4 hours? Not something like that's a whole day. And we would do them during the business day, so that if anything actually did go bad, if we need all hands on deck, it's totally easy to get it. And hey, you know what? The product owner was in there in the meeting anyway, so we got a leg up on it. I want to tell you about the background of this, because Basic Compact is interesting. I was looking for a nice image to put on this, and we play Yahtzee all the time. And so friends would come over that had never played, and we'd be like, hey, you want to play Yahtzee? And like, oh, I don't know how to play Yahtzee. Oh, it's okay, you'll learn, it's okay. And they get it, and they're really anxious about doing it, all these numbers, big grid. And then we start playing, and they're like, oh, it's poker. And their entire world changed. That's what the Basic Compact and sharing common ground is about. It's removing those assumptions, and then automatically you discover new things. You learn new things. So the way I want to wrap this up for you is to talk about resilience. A lot of talk about resilience engineering. There's a lot of talk these days about how DevOps, resilience engineering, and chaos engineering relate. Do they relate? Do they overlap? They kind of don't. Resilience engineering has been around for 20 years. Remember the book by Clark? Resilience engineering actually started around the time 3 Mile Island happened, beginning of the 80s. That's when researchers actually stepped back and looked at the sociotechnical system. They looked at how the operators in that nuclear plant are able to handle and control what's going on around them. They are part of the system that controls a nuclear power plant. Just like we are parts of the system that write software and deliver software. If you can recall back to when I was talking about the shakers, I talked about the shaker being diverse in type. We got 2 different types of shakers, diverse in sound, diverse in the way that they could be played. They're interdependent on me. I'm interdependent on the shaker. It's networked. I mean, you can play solo shaker, I guess. But usually you hear shakers in a band. It's networked with the band, and it's adaptable. Remember how I was trying to figure out how to play the shaker? Well, soon I got to adapt to what the band's playing, and then keep playing the shaker. So thinking about these things, thinking about music, I want to think about this quote. Improvisation, as Derek Bailey pointed out, is something that only exists in practice. It only exists when it exists. So music is not a property that improvisation has. Improvisation is music. It's something that improvisation does. Music is that goal. It's that goal that we've committed to. It's that emergent property of the complex system of us playing together in a band. So what do we do in the event that we have a fundamental common ground breakdown? We could rebound. Everybody could stop. We've gotten to the coordination surprise, okay? We could stop and return to the beginning of the song. We'll just start over. That's known as a rebound. You fall on the ground, you rebound, you get back up. Well, we could be robust about it. We could have a choice of actions. We could be robust to certain particular situations. We may have practiced enough together. We may be a strong enough band together that we're robust to this situation. And instead of having to start from the beginning, we can kind of like, quick stop, boom, next measure, next section, right away. We jump right back into it. That would be an example of being robust. But that's usually not how jazz works. Usually you don't want to stop the music. You want the music to keep going. This is known as graceful extensibility. Instead of stopping, we adapt. We recognize what's going on, we process it, we share a little common ground, we may communicate, we may share our observations with each other. You know, think about this in terms of a software incident as well. And we know that the incident's going to keep going, it's not going to pause with us, just like we don't want the music to pause. The incident's going to keep going, the music keeps going. But we want to remain cohesive, so we pull on that group intuition to get through this. There's a really interesting paper on cognition in jazz improvisation where they interviewed players, and they interviewed them after they played together. And they asked them independently what they were thinking. They didn't interview them together, the two people together. And one of the interesting things in the paper that they talked about was, oh, you know what, I heard that person doing this, and I noticed that they were kind of waiting a little bit on that, so I kind of ran with that and kind of played this other note. And they described how they adapted to an unexpected situation of that other person holding the note a little bit longer than the first person expected it to do. So that happens all the time in jazz. And you get these little motifs that you hear this in blues a lot. You hear it in rock songs all the time. The little blues licks, the little blue dun 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 dun. That's what I mean. Oh, we're in trouble. Let's just go back to that 12-bar ending and we can get through this song. That's the kind of highly resilient motif that they're talking about. It's an emergent property, and the complex systems themselves are emergent. So I didn't make up the improvisation music quote. I kind of stole it from John Uspaugh, who is another researcher, but also kind of famous for being the CTO at Etsy, who helped kind of kick DevOps into existence 10 years ago, 11 years ago now, I guess. And so he said this, it's not a property that systems has, this resilience. It's not something that you can, you know what, let's build some resilience into that system. Any complex system has resilience. It already has it. It has it by the nature of it being a complex system. So these four concepts, I already talked about the first three. They kind of build on each other. This is the paper by Dr. David Woods. That's the name of the paper, by the way, Four Concepts for Resilience. And he goes through these. The problem with the word resilience is that it's been misinterpreted and kind of taken and pulled apart and applied to things people call chaos engineering, resilience engineering. It's not. Chaos engineering is an important part of it, but they're not the same. So the thing that's the most important piece of resilience is that we're building our networks and our systems to have this adaptive capacity. We let the junior engineer run the game day. We let that junior engineer type the commands. So now as a team, we're building our adaptive capacity for the team to be able to help each other in these situations. Probably my most famous piece of complex systems, though, is diversity. And Sidney Dekker wrote some great things. He comes from aviation safety primarily, but a lot of people Sidney Dekker's work and applying it to software. If you've heard a lot about there is no such thing as human error trope, or there is no root cause, this is all going back to a lot of the research that people like Sidney Dekker is doing. And what they're seeing is that not only are complex systems themselves, by definition diverse, that's also the best way to understand them, is to approach them from a diverse perspective. So I want to leave you with this quote. Temple Grandin, anyone know Temple Grandin? She is, She is an autism researcher. She is autistic herself. There's a great movie, Claire Danes, I believe, plays her in this movie. She reinvented cattle farming. But she gave this great TED Talk. Go see this TED Talk, or go see it. It's on YouTube. It's 15 minutes. It's awesome. And what she talks about is the fact that the world, this adaptive world that we live in, it is itself a complex system. It's day by day ever growing more sociotechnical and more complex the more that we're interacting with it. And this world needs different kinds of minds to work together. It needs the kind of minds that think in pictures. It needs the kinds of minds who think in patterns. It needs the kinds of minds who think in words. All these different mental models that we all have about the systems that we run, the systems that we're building, we can't one person understand it all. We shouldn't expect ourselves to understand it all. We should leverage the fact that we are a diverse population. The human race is diverse, and the ways that we're creating this complexity in our software systems and our sociotechnical systems is getting out of control. Sidney Dekker would say, we're making our complex systems more complex faster than we're learning how to understand them. So the best way to approach them is to think about sharing common ground, sharing those mental models, bringing diverse teams together to solve problems, and really thinking about that practice of practice. When that software incident happens, it's not going to be an emergency. It's just going to be another day of normal operation for your complex system. Thank you. I do have some references here at the end. I'll leave them up for a minute or two if you want to snap some pictures. I will put the slides online as well. These are some of the papers and books that I used and researched, music and complex systems. There's some great introductions to Richard Cook's line of representation, How Complex Systems Fail. That's a really cool Twitter account, actually. Human and Organizational Performance has some great resources. And at the very end here, I listed every musician that I showed you and a piece or a track or an album or something that you can go and you can discover on your own the way that they use improvisation. It's one last page of it. Thank you very much for your time. Appreciate it.